Thank you for this another opportunity that you have given to me. I'm very particularly indebted to agriinformation.com, and this is possibly my ninth webinar that I'm conducting on irrigation and systems. So today's topic is very interesting one. How to actually a lot of people use rain guns and they wonder how to do the design. So I've tried my attempt to actually explain it in a very simple way, though it is quite a complex subject. So I'll start my slides. In this webinar, we will be dividing it into four parts. In the first, we will understand what is the meaning of a large volume sprinkler irrigation or a large volume rain gun system, and what are the different types of the large volume sprinkler irrigation systems that are available in the market, and how do you actually calculate an application rate or the rain rate. So, when the rain gun actually, like I have a rain gun over here, when it actually throws in a circular fashion, and it will be throwing water in the form of a circle. So how much water will be applied in an hour? So that is actually called as the application rate. And to understand this a little more in detail, we will actually look at it with the help of two examples for two crops, namely maize and sugarcane. So the definition of a rain gun or a rain gun is a very commonly used word, but the correct word technically is a large volume sprinkler irrigation system. A sprinkler which has got a large volume in terms of radius as well as the discharge is actually called a rain gun. And why do we need to have a rain gun? Because you want to cover a very large area with a fewer number of sprinklers or rain guns. So that is where the application comes in. And typically these rain guns have a discharge ranging from 10,000 liters per hour to 32,000 liters per hour for a single sprinkler. Like you have this, I have a bigger sprinkler over here, which will almost consume 32,000 liters. So you need to have, because of this huge requirement, you need to have an adequate source of water. And also because the radius will be very high, it will cover almost 24 to 36 meters, that is 80 to 120 feet. So one circle of a rain gun can possibly cover almost an acre or a little more than an acre of an area. So the horsepower requirement, that is the pump that will be required, also will vary. And starting with a small rain gun could be as low as 5 horsepower to 15 horsepower or even more. And where are these actually used? These are preferred for irrigating crops which are spread over very large areas, and you need to have an adequate water source and the availability of these high horsepower pumps. So it cannot be suitable everywhere. So these conditions are very important. Typically, they can be used for field crops, forage crops like fodder grass. We have successfully used these things for particularly for fodder grass and other crops where the grass grows to a great height. And even in plantation crops like sugarcane, coffee, and tea, it is a preferred method of irrigation because, like in coffee, you have two major times you have to give the sprinkler irrigation. That is, it's called as the blossom shower and the backup shower. And that is normally given by the help of these rain guns, because when the rain actually falls on the coffee foliage, then the bud setting actually happens. So therefore, this sprinkler irrigation is very, very popular, and we have installed these things for over 50 years and they are working very well. In addition to agriculture applications, we also have non-agriculture application. What I mean over here is you have a big lawn, or you have a big garden, or you have a big sports field like a cricket stadium or a hockey stadium, where you want to actually irrigate, or basically you want to bring down the dust. Say in a coal field, there you need the dust to suppress, or in a construction place where you want the dust to settle down. In such cases, these rain guns can be very useful because they will throw water, and the water will disperse in a very nice way, and the water will make all the dust particles to settle down. So these are all the applications of the rain gun. Now, actually, when we start the rain gun, like I told you, is a big volume sprinkler. We have very low sprinklers starting with a radius of around 8 to 9 meters. And if I take a model, say this M110 ST model, which is a very popular model, which is being supplied for the normally for the agriculture department, and all the farmers are using this. Typically, the nozzle can give you a radius of range from 8 meters to 16 meters, depending on the pressure that is available. What happens in the field, different pressures and different horsepowers are there, but it works for a very wide range. And all these sprinklers or these things do have two nozzles. They have one main range nozzle and a smaller nozzle, which is called as a spreader nozzle. So you will have to ensure that the water from one head of the sprinkler touches the head of the other sprinkler to have adequate overlap and the area is covered. So like that, different models. For example, this 110 ST will give you around a 40 feet radius. And if I take the 150 model, it will give around 80 feet radius. And this rain sprinkler, what you're seeing is actually a plastic model. And in places where theft is a problem, like people steal these sprinklers because of the brass value, in such cases, we also have engineering plastic rain operated sprinklers. So this is basically the low volume sprinkler, the first category. Coming to the second medium volume sprinkler or the mini rain gun, here the radius will vary from 16 to 24 meters, and these sprinklers are very popular in plantation, sugarcane and other areas and maize, which is the example that I'm going to actually explain to you. And we also have imported rain guns called the R series, which will actually give you from 15 to 24 meters. We have a R15 series and an R18 series. I was telling you about the coffee irrigation. There these R18, and the advantage with these things, you can adjust even an angle. Normally it's a 360-degree angle. You can adjust it to whatever angle you want, so that you don't want the water to fall on the other man's plot or the neighbor's plot. So you can actually adjust the angle that you want. Or if it's a hockey or a football stadium, you don't want watering outside the boundary of that particular layout. So you can have a part circle arrangement, and this will actually take care of. So part circle arrangement is something like this. You have clamps over here and it can be set to the desired angle. So these clamps are over here actually. So that is how that is the second category. Coming to the third category, that is the large volume sprinkler. Large volume sprinkler are really the big rain guns, which will have a radius right from 18 meters to 47 meters. So these are really huge sprinklers, and they require a high pressure, anywhere around 4 to 5 bar of pressure. As you can see, for say, for example, if I take ZNO 23, it is around 4 to 5 bar. It has to, that is 4 kg to 5 kg per square centimeters, and it will cover a very large area. So if you want, because you wouldn't want the sprinkler to be inside the hockey field or the stadium, it needs to be outside. So it can be covered. Or you have a very large coffee estate and you want to cover the whole area quickly. So then you can go for these kind of sprinklers. And particularly in uh, fodder grass areas and where the grass grows, you can actually fit it on a tripod stand, and then it can cover the required area, and it will give water in the form of rain. So this water is so uniform, it forms like a rain curtain nozzle, and the water will actually spread uniformly, and you are creating actually artificial rain. So now let us look at some of the technical part, which is very important. So first thing that you need to know is, you need to know how the water is actually falling on that area. That means it is called as the application rate or rain rate. I had explained this application rate in my earlier micro sprinkler um, session also. So just for you to, I have selected this particular ZL22 LOPS model sprinkler, and it has got a throw radius of 18 meter by 18 meter. So I'm showing you in the diagrammatically, in the circle form, these sprinklers are going to get overlapped like this. And I'm assuming an operating pressure, that you are having a pressure of at least 2 bar over there in the field. The discharge of each of the sprinkler is around 96 liters per minute. I will have to convert it to liters per hour, because all my calculations to calculate the application rate will be in liters per hour. So how do you calculate liters per minute into 60 will give me liters per hour. So it becomes 5,760 liters per hour. Now the application rate, I want to have a grid of 18 meters by 18 meters. What is the meaning of that? In the north, south, as well as in the east, west, my sprinklers will be moving in a grid fashion of 18 meter by 18 meter. So therefore, by knowing these two data, I can calculate the application rate very easily. So the application rate is given by the formula discharge of that sprinkler in liters per hour divided by the grid spacing. So here it is 5,760 divided by the grid spacing is 18 by 18. So it will come to 17.778 liters per hour per square meter. I had explained this concept. So liters per hour per square meter is nothing but straight away millimeters. That means if it is 1 liter per square meter is nothing but 1 millimeter per hour. So you are going to apply around 17.78 uh, millimeters per hour for that whole area when it operates for 1 hour. Now, let us say the crop that we are going to irrigate now is going to be maize, and it requires around 2 inches or 50 millimeters per day. That means how many hours will you have to operate? So you have the irrigation hours. It's very easy to calculate. You know that 2 inches is nothing but 50 mm. 50 mm divided by the application rate of the sprinkler, which is 17.78. So it will work out to somewhere around 2 hours, 2.87 hours. That is nothing but 0.81 multiplied by 60. So roughly 2 hours and 48 minutes. So you can take it as around 2 hours and 45 minutes. So that much if you are going to operate the sprinkler, you are going to apply the required water that is required for maize. So this particular model of the sprinkler actually is a very economical model, and it was developed from the market, that farmer who is even having a very small horsepower, say 5 horsepower also, will be able to cover a good maize plot, and the whole area can be quickly covered. So these are all the basic features. It has got it's an aluminum body, so there is no rusting. It has got a stainless steel spring, which is very good, and the throw radius is from 18 to 24 meters, and it can cover a very good range from 2 to 3 meters. And this is also, like I told you, it has got a part circle arrangement in case you want to have an angle lower than 360 degrees, even that is possible. And it has been very successfully used in in maize, fodder, and coffee, tea, and sugarcane plantation. Now let us understand this whole exercise with the help of an example like how I had taught the drip design. So now I'm assuming a plot which is around 100 meters by 200 meters. So that means the area is exactly 2 hectares. So 100 multiplied by 200 is 2 hectares. The water source actually is a tank. From the tank, we are going to supply water to this particular area. And the water quality, we are assuming that it is normal with a very minimum quantity of silt. Mind you, in a drip irrigation system, normally we provide filters. But in case of these rain guns, we don't need to actually provide any kind of a filtration, because what happens, the nozzles are pretty big and they're quite, and anything that is there, except for covering the footwell with a wire basket, nothing else needs to be provided. And in this particular plot, we are assuming a grid of 18 meter by 18 meter, which I told you 60 feet by 60 feet. And we are assuming that we are going to get power only for 8 hours, whether it is electrical power or the manpower is available only to irrigate for 8 hours. And beyond that, we don't have because it is very practical. And the irrigation cycle, basically irrigation here cycle here refers, if I irrigate one plot, when do I come back to that same plot? Uh, it will be after 7 days, basically, because that much water retention will happen, because the kind of soil that is there is a red sandy loam soil, and there will be quite a thing. So if the soil is very clayey kind, you can go up to 10 days. If it is very sandy, you should keep it around 7 days. So this is the recommendation that is given in the engineering part. So now when we want to do this, we let us look at it step by step. So over here now we have taken the ZL22 sprinkler, and the grid we have assumed is a 18 meter by 18 meter. And as already I told you in the calculation, it is going to give you, each sprinkler is going to give you 5,760 liters per hour. Now the critical step over here in case of a rain gun or a sprinkler design is basically the irrigation scheduling. We already understood that there is no power not available more than 8 hours. So now if you look at the area covered by the sprinkler, you can do it in two ways. I am doing it in a very simple way, because ultimately it's going to be a square, though it throws in a circular fashion. Area is nothing but a square of 18 meter by 18 meter, which is around 324 square meters. So now you have to cover an area of 2 hectares, and each sprinkler is going to cover only 324 square meters. So how many positions will come? So 20,000 square meter is 2 hectares, divided by area covered by one sprinkler is 324. But that becomes too much of a shift that I have to keep shifting around 62 shifts. So what I will do is I will tell, okay, let me go for 3 number of sprinklers. In this particular case, instead of operating only one sprinklers, I will take 3 sprinklers. So I am assuming this. And therefore, by doing this, I am going to reduce the shift 62 divided by 3, that is only 21 shifts. So in 21 shifts, I can complete the whole irrigation. Now, the peak water requirement, for example, in a particular place is assumed to be 5 millimeters per day. And already we have calculated the application rate, like I told you, the discharge divided by the grid spacing, and that we had got as 17.78. And the irrigation cycle for maize is going to be around 7 days based on the soil of sandy loam over here. The irrigation scheduling, further we have to find out how many hours we have to work for each shift. This I already told you. The peak water requirement into the irrigation cycle. So 5 millimeters, an irrigation cycle for me is 7 days, and application rate of each sprinkler was 17.78. So it is going to roughly operate for 1.97 hours or 2 hours. Okay. So that means if I already calculated that there is going to be 21 shifts, and each shift is going to be operating for say 2 hours. So that means what happens, 19.71 multiplied by 21, that is around, so you take it as around 40.69, or say 2 into 14, say 42 hours is what is going to happen. Now you know that you have to complete this entire irrigation circle within 8 hours only. So is my design all right? Let me go back and check that. So the total working hours over here is coming to say 40.69 or say 42 hours, and I am having an irrigation cycle of 7 days. So it's only going to come to 5.8 hours or 3 shifts. So it is definitely going to come less than 8 hours. So our design or assumption, you can even take 3, or even you can try for 4, no problem. This is an iteration which you can try out. And therefore, in this particular example, I have taken around 3 shifts, and therefore, so less than 8 hours, I am able to complete my irrigation by providing 3 rain guns. After you have calculated the shift, next you have to calculate, because you need to know, also tell the farmer what is the horsepower that will be required. So in order to do the head loss calculation, this I had given a very easy method last time also. So there is an elevation in this particular plot from the water source to the highest point is around 5 meters. There is a high, the plot is at a 5 meter higher level. And for this particular sprinkler to operate, I told you there is an operating pressure. That means the pressure which is required at the nozzle, at the inlet over here, is around 2 kg. So we have to add that also. And suction. Suction is the distance of the water from the into the what from the water level into where the footwall is going to be there. So that is roughly normally not more than 2 or 3 meters is what the normal suction depth will be. And then this particular thing sprinkler is going to be placed on a tripod stand. So that means you have to take the pipe up to 2 meters height. So you have to add that 2 meters also. And the mainline friction loss, like I told you, either you use the Hazen-William formula or you can go for the thumb rule, which I told you 2.5% for every distance or the length calculated. And by working out that, it works to roughly around 6 meters is the friction loss. That is when water passes through the pipe, it rubs against the walls of the pipe. So that causes friction. So that frictional loss is around 6 meters. And this pipe will not be going straight. It will be going through bends and tees and fittings and other things. So roughly around 4 to 5 meters of losses will happen in the bends and fittings. So that also has to be considered. And then in the portable pipe, the sprinkler will come into a main line and then it gets into a portable line. So in the portable pipe also there will be some friction loss, which is generally less because it is a pipe having outlets. So when a pipe having outlets, the friction loss generally will be less. So there we are assuming it to be around 2 meters. So if I calculate the total head that is required, is the sum total of all this will be working out to around 41 meters. So I need 41 meters pressure. So I have calculated the head. I also know the discharge. Once I know the head and discharge, then it is very easy to calculate the horsepower. So let us see how to do that. So the pump set, for example, I told you there are three sprinklers are operating, and three sprinklers, the total discharge of the sprinkler will be 4.8 liters per second. Mind you, when we are using the horsepower formula, the discharge has to come back in liters per second only and not in liters per hour. And the total head requirement just now we calculated is around 41 meters. And typically the pumps in India are having an efficiency of between 57 to 65%. So an average value of 60% I have considered as the efficiency. To calculate the horsepower, it is very easy. The formula for the horsepower is the discharge of the sprinklers multiplied by the head and divided by a constant 75 and divided by the efficiency N, that is 60%. You have to take it as 0.6. Okay, 60 divided by 100 is 0.6 over here. So when I do the math over here, 4.8 into 41 divided by 75 and divided by 0.6, I get a theoretical horsepower of 4.37 horsepower. Say you will not get in, it's always a round number. You get a 3 horsepower or a 5 horsepower or 6 horsepower. So this can be rounded up to a 5 horsepower. For example, you also have to select your pump in such a way that my optimal performance, we call it as the duty point. I had explained this in another webinar where when you have the head versus discharge, at the point where the efficiency of the pump will be the highest, that is generally the mid range. So please select that pump in that particular range. And I have just, courtesy of Kirloskar Brothers, I have selected a 5 HP monoblock pump set, which is actually going to do the purpose. And this is how it is going to work. To do this calculation, you need not worry. Actually, an Excel sheet is there. As Excel sheet, every detail will be there over here. Excel sheet, you just need to punch in the data. So you have the area, you have the area of 2 hectares. What is the crop? What is the thing? And what is the type of soil? What is the kind of sprinkler that has been suggested? And then what is the throw radius that is there? What is the operating pressure? What is the peak water requirement? Just punch in the data and automatically the entire calculation for the discharge number of ships, what is the irrigation cycle, and the entire thing will be worked out. And as you can see, the complete calculation is worked out over here. Whatever I explained to you in the step by step, it is just summarized in an Excel table, and it's very simple. You can develop this Excel sheet very easily, and therefore we will arrive at the entire thing. So how is this going to be laid out? This is how it is going to be laid out. So you have the tank over here. This is the plot 100 meters by 200 meters. And this is the main line that is going to come at the edge of the plot. And you are going to have these shifting positions of the sprinkler line. So this is the dotted line is the sprinkler line. And there are going to be 3 rain guns or 3 sprinklers over here. And like I told you in the calculation, we have 3 sprinklers operating at a time. And there are 62 positions for this entire area to be covered. And the irrigation interval is 7 days. So here, going by the hydraulics of the design and that is available. So a 75 millimeter 6 bar high density polyethylene pipe can be taken over here, and a sprinkler line of 63 millimeters 4 bar high density polyethylene can be done. So how to do the hydraulics and all that, the discharge calculation I had given to you in my earlier webinars also, how do we select. So you know that 75 millimeters can go up to say 25,000 liters per hour, and 63 can go up to about 12,000 liters or 14,000 liters per hour. So within that operating range, you will have to actually select the sprinkler, and then you have to make out this design. So this completes the assignment of the first part, that is the simple one, that is the mini rain gun. Now let us look at the second example where it's a much bigger plot. I want to cover a sugarcane plot which is around 5 hectares. The dimension of this plot is 200 by 5 meters, 250 meters. And the water source now is a river. From the river, I have to pump this water, which is very typical. If you take a country like Africa or India, any place, you have to get the water from a very long place, and then the water source has to come and irrigate this entire area. And I want to plant sugarcane. And the crop being sugarcane, this particular sprinkler is a big sprinkler, and therefore I have taken a grid of around 36 meters by 36 meters. That means the sprinkler in the north, south, and the east, west is going to be 120 feet by 120 feet. So sprinkler is going to cover a very large area. And here the soil, since it is a clay soil, that means the water holding capacity is higher, and therefore the irrigation cycle or the interval will be 10 days. I don't need to irrigate it every 7 days to complete the cycle. So therefore, I will keep the irrigation cycle a slightly longer. So the soil will decide what kind of irrigation cycle. And working hours typically not more than 8 or 10 hours, because labor will not be available beyond that. If you can increase the working hours, then of course you can have more number of sprinklers. So for this particular example, I am considering only one rain gun that is going to operate. So here we have selected a big sprinkler, which is called as the ZNO23, which is a part circle, and it's made of aluminum alloy, and it's a gunmetal coated powder coated thing, and it covers a very good, and it has got a flange connection. Advantages of a flange connection is you can dismantle it and do all the repair work very easily, and it has got a throw range of 25 to 45 meters, a very large area. And typically this is used in the even in sports field and other dust suppression areas where you don't want the sprinkler to be an obstruction anywhere. It will just be at the edge, and you can cover the whole area. And the discharge, as the sprinkler is much higher, the discharge range also will be higher, and the pressure required also is higher. And you can also have the part circle arrangement in this particular sprinkler. So if you want to cover only a particular area, like particularly in a stadium, you will have to have set it normally at the 180 degrees, not at the 360 degrees. So now let us now look at this example. So again, the steps will remain the same. So first thing you will have to do is you should need to know how much is the application rate or the rain rate, how much water is being thrown on that area. If I put the sprinkler or the rain gun at a 36 meter by 36 meter grid, and the pressure that is required at the inlet of the rain gun. So a typical rain gun, at the inlet of this rain gun, what is the pressure? Is around 4 kg or 4 bar. So with this kind of pressure rating, and each gun, mind you, is going to take a discharge of around 41,500 liters. So it is really, you can see the discharge is really high. And with this 36 meters by 36 meters grid, the application rate is very easy to calculate. It is nothing but the discharge of the sprinkler divided by the grid spacing. I am using the same formula. So 41,500 divided by 36 into 36 will give me 32 millimeters per hour. That means it is going to give me almost 32 millimeters per hour. That means it is going to cover that entire area with this kind of an application rate. And assuming that this is a sugarcane crop requiring around 2 inches or even 2.5 inches or 50 millimeters per day, I need to irrigate only 50 divided by 32, say 1.56 hours. Say 1.5 hours is more than enough. That should have been 1.5. 1.5 hours, you can complete the whole area and give the application rate of 50 millimeters per day. Now going step by step on the calculation, the crop is sugarcane. I have selected the bigger model rain gun, and each rain gun has got a discharge of 41,500 liters per hour. That is 11.53 liters per second. How did I get that? 41,500 divided by 3,600 will give me 11.53. Because from LPH to LPS, you just have to divide it by 60 into 60. That is what has happened over there. And coming to the irrigation scheduling, like we already told, not more than 8 hours. So 8 hours is the time available. And area covered by one sprinkler is 36 meters by 36. So 1,296 square meters it can cover. But the whole area is 50,000 hectares, and it can cover only 1,296. That means if you divide the 50,000 by 1,296, you are going to have a 39 shifts. Now, if the peak water requirement, we are assuming around 6 millimeters for sugarcane, And the application rate, when you want to actually calculate it like the previous one, it is around 32 mm, which I already explained to you. And the irrigation cycle, I am keeping only around 10 days because this is a medium soil or a red loamy soil where the application rate can be little bit, the number of days can be little bit extended. Then after once you have calculated that, then we'll come to the working hours for each shift. To calculate the working hours of each shift, you know the peak water requirement and you have to multiply it by the irrigation cycle and divide by the application rate. So I have peak water requirement of 6 millimeters, irrigation cycle of 10 days and divided by the application of 32 mm, that what we saw, it's going to come roughly around 1.87 hours. But we know that I have to map 39 positions to cover that 5 hectares. That means what happens is, so that means 1.87 multiplied by 39 is going to give me the total working hours if I have to complete it. So that means it is going to take almost 73 hours. So we want to see whether I can, we are going to operate and since we have a 10-day cycle, so per day if I calculate, so 73 divided by 10 days, I am going to get 7.3 hours. That means basically you are going to have roughly around 2 hours, say 4 into 2, it will be 4 shifts. So 4 shifts, so 4 positions of the sprinkler will get covered in the time period of 8 hours. After you have done, you know that that means you are going to shift it like this, and in 10 days, every 4 shift, the entire area is going to get covered. So once this has been completed, then you need to get into the head loss calculation. The elevation in this particular plot from the river into the plot is around 12 meters. It's quite a steep elevation. And the mainline friction loss, the length, again, you will have to actually calculate it, whatever is the friction loss. I am just for the simplicity of working, I am assuming it is going to be around 3 meters. But the operating pressure over here, unlike the earlier sprinkler, which was just 20 meters, now it is going to be 40 meters. So therefore, 40 meters is nothing but you have to add it up. And the suction from the river, the depth that is there is around 2 meters. And the riser pipe, which you need to take the pipe up so that it can cover the whole area is around 2 meters. And the valves and fittings, you are going to have water flowing and you are going to have friction loss in that. So that will be around another 4 meters. And the friction loss even in the sprinkler line, or as we call as the portable pipeline, will be around 2 to 3 meters. So that is all added. So when you actually total up all the head losses that are over here, the total dynamic head is coming to 68 meters, unlike the earlier problem where we got only 41 meters. So that means this is a bigger rain gun covering a larger area, and therefore the dynamic head or the head that is required. So therefore the horsepower requirement is also definitely going to go up. So when you look at the pump here, the discharge is going to be 11.53 LPS because only one sprinkler is operating and the total dynamic head is around 69 meters and the pump efficiency, like I told you, is only around 60%. So basically, when you have a 60% efficiency, it is 0.6. So let us do the math again. The horsepower is given by the formula discharge into head divided by 75 and divided by the efficiency of the pump. So that actually works out to 11.53 multiplied by 69 divided by 75, which is a constant when you do it in this particular metric system and divide by 0.6,
Yeah,
will give
regarding
you
what?
around 17.68 horsepower, say 18 horsepower pump. So again, you will have to go to your pump chart and check, or you can just go to the
From?
pump manufacturer and ask
Yeah.
them, so this is my particular head and this is my particular discharge. What would be the suitable
Not
pump for it?
interested. Thank you.
So automatically you will get 18 horsepower pump set. So here again, I am just for courtesy sake, I have taken a Kirloskar, which are surface. There are many pumps that are available and pumps that can be put inside, like submersible monoplow pump also can be put inside, and therefore the calculation can be done. So to make this entire process very simple, an Excel sheet can be used. And here again, the area is 5 hectares and the crop is sugarcane. The water source is the river and the type of soil you can mention. And what is the kind of sprinkler that you have adopted, you can tell. And the throw radius we have considered for this design, that also can be measured. And what is the operating pressure at the nozzle? 4 bar pressure is required. Each sprinkler has got 691.66 LPM, or what you saw that in LPS, and peak water requirement of sugarcane is around 6 mm per day. And sprinkler spacing, the grid is 36 meters by 36 meters, and each sprinkler we have just converted it, so it is 41,500. And the application rate, I already told you how to calculate. You have to take the discharge of the sprinkler divided by the grid spacing, you're going to get 32 millimeters. So that you have actually calculated, and the liters per hour 41,500, and you have converted it. I have given all the possible calculation because people do it in liters per hour, do it in liters per second. Also, some people do it in meter cube per hour. 1 meter cube per hour is nothing but 1,000 liters. So basically, 41,500 divided by 1000 will give you 41.5 meter cube per hour. And now coming to the scheme of operation, which I explained again, that is also it's a 10-day cycle, and working hours for each shift we calculated is around 1.87 hours, and the maximum number of working hours is 8 hours. So each shift will take around 2 hours. So 4 shifts are going to come, and the total number of shifts that has to be covered, we already saw that that is for the 10-day cycle is going to be 39, and the total working hours to actually complete over here is actually going to be 73 hours for the total, but per day it is only going to be 7.31. So that is very easy. After that, we have to finally recommend the farmer what is the pump that is required. The discharge of each sprinkler, that is 41,000. You already seen the calculation. 41,500 is nothing but 11.53 LPS. You have to keep it in LPS and head in 68 meters. Efficiency is 0.6 or 60%. So the same calculation has been done. Q multiplied by H divided by 75 divided by N will work out to 17.42 or say 18 horsepower. And you can also multiply it by 0.78 and you will get it into the kilowatt. So 13.42 kilowatt is the requirement over here. So the final arrangement, so you see how the entire thing, this is the river and this is around 50 meters away and this is your main pipeline and this is the kind of water that has to be carried. So only one particular gun is going to operate at a time, and since the pressure, the total dynamic head came more than 60 meters, I have selected a 110 mm 8 bar STP pipe, and from here, and these are the different positions. So like I told you, so you will start shifting it around. So this is a sugarcane plant, only one number sprinkler operating. There is going to be say 39 ships or say 40 ships from one end to the other end, and the irrigation interval is 10 days. So that is how the sprinklers are moved around, and the entire area is going to be covered. So the entire area of 5 hectares can be very comfortably covered. So this is just to show you how the rain guns work. You can see how beautifully the rain gun is throwing. It literally gives you the water in the form of a very fine nozzle, and the water forms. These are called rain curtain nozzles. The water literally forms like rain, and it doesn't disturb the plant and all that, and it gives very good advantage with rain gun is also it will also keep the foliage clean. So that's another advantage where and particularly when you want to have this if it's a fodder grass and you want to feed the foliage to any kind of animals, particularly in the goat farm where we had installed. So the leaves also get cleaned and they're able to get ready-made fodder. So this is another plot where it is installed for vegetables. So these are the rain guns actually which are in operation. So this is basically I have tried to cover to you that so rain gun is nothing but a large volume sprinkler, and the large volume sprinkler, depending on how you want to make the design, whether you want to, and everything is decided by the working hours and how much power is available, or whether you want to have a diesel engine pump set. So accordingly, you can go typically 6 to 8 hours. If more labor is available and they want to have it for a longer period, it can be done. This can actually, if you want to go for higher hours, it would be good to automate the system. So you can even go for automation, whereby the solenoid valves will take care of the irrigation and the irrigation will happen in the desired fashion. So this is the end of my session, and I hope you've been able to understand. You can always go through the video again, and because a lot of technical calculation is there. And I'm very thankful again, once again, to agricultureinformation.com. So basically, I'm in this field of micro irrigation for quite some time, and my one of my passion is to teach and to share this knowledge that I have gathered over the last 35 years to the farmers, and so that because people used to tell design is a taboo, design is not a taboo, design is very easy. You just have to get into the mathematical. And I feel anyone with basic knowledge and technical thing who can understand, I made it. That's why I made my own simple steps for you to understand. You may not get it in a regular textbook, but then this will make you to understand the whole process very easily. So thank you very much, madam. So now I will stop sharing my slide.
Thank you, Mr. Vijay, for the detailed presentation. Now I'll take up some questions. Okay. Mr. Brito, you can ask your question in the meantime. I'm trying to get the questions from my side.
Good evening, Mr. Vijay Kumar. Very useful presentation.
Thank you.
Of course, in coffee, sugarcane, and tea, it is very common to see this. But What about a small vegetable farm which is growing, say, crops like carrot, brinjal, tomato, peas, gourds? Do you have a small sprinkler for that which is suitable?
Yeah, yes, we have very
What is the
small
cost? Yeah.
we have very small sprinklers, the plastic sprinkler, like I showed you. It's a very small sprinkler,
Yeah.
and it will cover a radius of around 8 to 10 meters. They are not very expensive, hardly around 400 to 500 rupees each sprinkler. That's it. And if you want even
Okay.
smaller sprinklers than that, you have what is called as a micro sprinkler. And a micro sprinkler will hardly cost you 40 rupees. And you have to put, because nowadays farmers are using these micro sprinklers very popular to irrigate the small gardens. Like if you
Okay.
go to the rural area,
Yes.
particularly for carrots and for leafy vegetables and all that. So
Yes.
there is a micro sprinkler. In fact, I had made one complete session on you can go and refer that also. I have told how to do the design for even a micro or a mini sprinkler. So those
Okay.
sprinklers can be used, and that is also easily available. Yeah.
Okay. Okay. Thank you.
Okay. So initially, there are some basic questions. What are the main components required for setting up a rain gun irrigation system?
Yeah, yes, madam. It's a very basic but a very important question. So first thing, like I told you, you need to have an adequate water source, sufficient water, because rain guns cannot be adopted everywhere. And number two is you should have an adequate horsepower. The pump horsepower should also be sufficiently adequate. At least you should have a minimum 5 horsepower. So these two will be basic requirement of the horsepower and the kind of availability. You should have a reliable water availability. You can't try to connect it to a borewell which has got say 1 inch or 1.5 inch, because what will happen, the pressure that is coming out with which it comes out will not be adequate. So in such cases like Mr. Joseph just now asked, we can go in for the smaller nozzles. We can go in for smaller sprinklers which will not consume much water. The discharges of that will be like 100, starting from 100 to say 1000 liters per hour only. And when the discharge comes on, automatically the range also will be different. Yeah.
And could you explain how rain gun irrigation differs from traditional drip and sprinkler systems?
Yeah, this is again a good question. And see, I had done my first session on the efficiencies of the various irrigation system. A drip irrigation system typically has an efficiency of 90 to 95%. What is the meaning of that? It means that for every 100 liters of water, around 90-95%, 95 liters is actually reaching the plant root zone. Whereas a sprinkler or a rain gun is actually going to have an efficiency of 70 to 75%, because some amount of water will be lost due to the wind effect and due to the water falling in areas where it is not required. So that will be one difference. And flood irrigation, which is of course the conventional method of irrigation, which is a very low efficient system, will be around hardly 30-35. 65% is wasted by the water moving through the canals or through the channels that is there in the field or through deep percolation. So when we all tell that if I have say water, say 1,000 liters of water, I can do 2 acres of 1 acre of flood with 1 acre only flood irrigation. I can, with the same water, I can cover 2 acres of sprinkler, and with the same water, I can cover around 3 acres of drip irrigation. So that ratio of 1:2:3 is a very commonly used ratio, and that is how this it comes in a middle efficiency. And if you take worldwide also, flood irrigation still is majorly adopted because there is no investment involved as except for the labor. And in countries where labor becomes expensive, people go in for these things. And with water scarcity becoming a very major issue, so therefore it is better to go for these good methods which actually will efficiently use the water, and also you are going to have a uniformity not only in terms of the irrigation but also in terms of the fertigation. So fertigation also in drip irrigation, fertigation also can be done. And in rain gun, you will have to see, because if it is going to fall on the foliage, some of the fertilizers cannot be applied. But there are some advantages also in sprinklers. You can apply certain fertilizer over the foliage. Yeah.
Okay. And what are the advantages of using rain gun irrigation in agriculture fields?
Rain gun irrigation, I will recommend only if you have a very high density of planting, madam. That is one very important. For example, if you go to a place like Shimoga, or you go to a place like Kodagu, or where you are going to have multi-layered crops, and if you try to go for any other system, it is going to become very expensive. The advantage of a sprinkler or any rain gun, it's a portable system, and therefore it makes the cost very economical. So the cost becomes economical, and if you have labor to shift it around, then it is very much viable, and it basically they are very trouble free. Drip irrigation has a maintenance component that is always there. You have to maintain it. There are chances of the drippers getting blocked and all that if you don't maintain it correctly. Whereas a sprinkler nozzle is very relatively very simple, and anyone in the farm who knows how to just open a spanner and just clean the nozzle, put it back. So it's very that simple to operate. And whenever we go to a farm, we always tell you graduate from flood into sprinkler, get used to sprinklers, and then get into drip. So that graduation will help the farmer to understand, and therefore in terms of operation convenience and in terms of certain advantages which I already told, the sprinkler and rain guns have definitely have advantages, and which I have already explained.
Yeah, okay. And how do you determine the optimal placement of rain guns within a field for efficient water distribution?
Yeah, so I told you the basic principle that we adopt for what we call, what you said, optimal water distribution or the overlap. What you're talking of here is the overlap. So the water from one sprinkler should actually hit on the head of the other sprinkler. That means the radius of the sprinkler will actually will determine what is going to be the grid. If I don't want to have a very 100% overlap, maybe I can spread it a little more. Maybe I can go for an 80% overlap. If it is a lawn, we need complete overlap because we don't want any dry patches. But if it is a field, I can go for a slightly wider spacing, and it will also bring down the cost. So that will depend on, that is one part of it. The second part of it is the soil type. So how is your soil? Is your soil a sandy soil or a sandy loam soil, or is it a clay or a black cotton soil? So based on the soil type, you will decide on the irrigation interval. So if it's a sandy kind of soil, you would have to have a close irrigation interval. You can understand that when the water is sprayed in the rain also, if it's a sandy soil, after 2-3 days or 4-5 days, the water would have completely got percolated and nothing will be there. Whereas if it's a clay soil or a black cotton soil, you will not be even able to walk in the field because the water will take a longer time, because the water is held in the soil, and for it to percolate and get drained out, it will take a longer time. So you can have a irrigation cycle of around 10 days over there. So this from 7 days to maximum 10 days, you can have the kind of cycle that you want to have.
Okay. And can you provide examples of crops and or fields where run gain irrigation has been particularly effective?
Yeah, rain gun has been very particularly used in the plantation sector, that is coffee, tea, and sugarcane. Also, it's used in the forage crops like fodder grass and other areas. And in certain areas, it has also been used for maize and all that. But again, you will have to keep in mind that if the water spray is very heavy, then if the plant rooting system is a very shallow, then you will have to be careful. You will have to go select a nozzle which is going to throw water more in the form of a rain and not heavy particles of water. The main concept you will have to understand in a sprinkler is, when I throw water, I want the water to percolate, not disturbing the roots, and it should not start runoff. It should not start running away from the field. That means your design is not correct. The water should percolate and the water should go down to the roots, and a very little runoff should be there. So that will be very critical. So we always say the application rate of the sprinkler should match the infiltration rate of the soil. So that if you take care, and that actually that is what we say the irrigation. So based on the various soil types, we can actually recommend the kind of irrigation interval, and we can actually, you can, once you start using the sprinklers, you will come to know that okay, my soil is like this, and should I have an irrigation cycle of 7 days or 5 days? And again, like I told you, the evapotranspiration or the water loss that is happening in the crop actually will also vary a lot, and that will actually depend on the kind of climate that is there in the area. So it can vary. Some area the water requirement may be 6 mm, some it may be 8 mm. So it depends. So accordingly, you will have to do your delivery.
Okay. And what are the typical water requirements for operating a rain gun irrigation system, and how does it compare to other methods?
So the water requirement of the rain gun, like I told you, like when we did it for the two examples, I had taken 5 millimeters and 6 millimeters. So basically, when we do this, the irrigation interval will be anywhere between 1.5 to 2 hours. Now, if you take coffee, for example, you have two critical irrigation. One is the blossom shower, where we give a 1.5 inches of rainfall, and The backup shower is, which is again a 1.5 inches rainfall. So you have to understand the agronomy of the crop and what is the kind of water that needs to be given. And accordingly, you have various sprinklers. You have combination of sprinklers and rain guns, which actually can be used, and you can cover the entire area. And evapotranspiration, mind you, is a climatological factor. It depends on the temperature of that area, the kind of, it is a very hot day or a thing, and then how much water can be retained in the soil, how much evapotranspiration is happening from the leaves and the surrounding soil. All these parameters will come into picture.
Okay. And are there any specific maintenance tasks or precautions farmers should take when using rain gun irrigation?
The rain gun system irrigation are basically very trouble free, madam. Only thing, one mistake what farmers do is they try to, when it is not operating this gun, what they try to do is the spring they try to put oil. That should never be done. This is a water lubricated sprinkler. Never should you apply thing. That is one care you have to take. The nozzles are all openable. Every nozzle can be opened with the help of a spanner and it can be cleaned and put back. So maintenance is actually very minimum. And in order that if the water source is like a river or a tank, what you do is around the foot valve, you put in a wire basket so that big chunks of algae or other moss will not enter. And then the water is actually pumped into the system and then it takes. So, compared to a drip irrigation system, a rain gun or a sprinkler is very much trouble free and the maintenance is actually very minimum. Once in a while, you may have to change the spares of the washers or maybe over a period of time. But these are trouble free working from 20, 30 years, they work very well. And if there is any issue, you can always come back to our godown. We will just open it up and just change that spring or something and put it back.
Okay. And how does the design of the irrigation system change based on factors like soil type, slope, or crop variety?
Yeah. So here what happens is like if you take a coffee estate, what happens, coffee estates have got huge elevation. So initially in the areas closer to the coffee garden, we'll be giving around 6 or 7 sprinklers. And as you go higher and higher, the pressure will drop and therefore we will not be able to operate 6 or 7 sprinklers. We'll be operating only 4 or 5 sprinklers over there. So you will have to do a fine tuning based on the topography and the terrain of the area and how much pressure is available. So when you actually connect your sprinkler, it has to throw the minimum radius, and I would suggest to have pressure checking points along the pipeline. So when you put a pressure over gauge over there and check, yes, I am getting around say 3 bar or 2.5 bar. If my pressure is right, my radius is going to be right, my coverage is going to be right. If that you cannot do it, then the only option is if you are operating say 5 sprinklers, maybe I'll have to cut down 1 sprinkler and maybe operate only 4 sprinklers. So that kind of fine tuning definitely has to be done in the field, and that most planters and most farmers very easily understand this and they very easily adopt to it. Actually, it is not at all difficult.
Okay. And could you share any cost benefit analysis or economic considerations for implementing rain gun irrigation?
Cost benefit analysis as such, I don't have at the moment, madam, but it can always be worked out. It's not a problem, but I can tell you what the planters tell me. The return on investment is easily, you get back the return on investment in about 2 to 3 years. So whatever you have invested, you get it back in about 2, 3 years. And after that, it is all a surplus only for you. And the convenience, because what happens in coffee, for example, if I don't give irrigation at the blossom and the backup, my entire crop for the year is gone. So it is such a big risk if I don't have a good sprinkler or a rain gun system. And with the kind of erratic monsoon that we have and the climatic patterns and the changing thing, a sprinkler irrigation or a rain gun irrigation is a very good insurance against this kind of erratic pattern. And you know that the monsoon is not being consistent. When sprinklers came into India and the way back in Premier introduced it in 1965, the reason it came was because the rainfall pattern started varying. Otherwise, it was all rain irrigated. It was not irrigated by sprinklers. But when that failed and the entire crop hard work that has been happened and your coffee entire crop will go. So like that, so it becomes very critical. So sprinkler irrigation is actually a boon and it definitely will take care of the, particularly in whatever available water, you can distribute that water in a distress period. You can distribute it over the entire area rather than if you had flood, then you had to. It is practically not possible now, madam, with the kind of water availability that is there and the kind of depleting water table, we will have to only go for these kind of efficient irrigation systems.
Okay. So now we have the last question. Can you recommend any resources or case studies for further understanding and implementation of rain gun irrigation systems?
You can always contact me, madam. I can give you the kind of references, and also you can visit our website www.pial.in, or you just type Premier Irrigation, and once you get into Premier Irrigation, all the technical specifications, and we also have a YouTube channel where many of our plots are shown how the water is being irrigated and how the examples, how the farmers are benefited. So a lot of information today is available in our own website and our YouTube channel. Definitely you can subscribe to that, and you can get it. And if you have any particular query, I'll be very happy to help, because my belief that knowledge is only to be shared and to be given to more and more people. And that's the reason I, in fact, got in touch with Agri Information, and you have been very kind enough. And you have given me the 9th session actually. So all these sessions actually help our farmers, because we have to demystify the whole thing. We have to make it simple for them to utilize it, because when the water is becoming such a scarce resource, we have to enable the farmer and the planter with tools so that he will be able to do his irrigation correctly, and with the available water, how best he can go about the irrigation.
Yeah. Okay, Mr. Vijay. Before we end, Mr. Brito, you would like to ask any further questions?
Yes, thank you. Mr. Vijay Kumar, could you tell for coffee plantation of about 25 to 50 acres, what will be the cost of a simple irrigation system, rain gun, like you have done for Mr. Pereira, no, Anand Pereira?
Yeah.
And what will be the lifetime of that?
Yeah, so actually, we'll have to normally the process is we get the area surveyed, and then we have to work out the pump and the horsepower requirement and all that. If I start from a very small level, like a small farm, the sprinkler set will cost you around 25,000 rupees an acre. And going on the upper side, if I want to cover a large area, so if you want to go with the rain gun, so it can again go up a little more, and really to give you an exact costing, because there are three types. One is a permanent system where you have the sprinklers fitted, or you have a semi-permanent system where you have the main line and then you have the subline, and then you have the which is typically adopted by the planters. And then, of course, the pump set and engine part is separate. So that kind of calculation. So we will be very happy to have your land, because what I say is irrigation systems are tailor-made. I'm just giving you a ballpark estimate. Actually, the correct estimate would be to visit your farm, take out the elevations and other the Google survey and all that, the GPS survey, and after that we will be able to give you an accurate. I can tell you one thing is, as the acreages increase, the cost per thing will definitely come down. So it is not going to be. It's very much viable with the kind of thing that is there. So for example, in the agriculture, like I was telling you, the fodder grass. So it is hardly around per acre cost is around 25 to 26,000 rupees only per acre. So that is the kind of cost that comes in.
Okay, thank you very much. I get your point.
Yeah,
thank you so much.
Thank you for attending the session, sir.
Yeah. Okay, Mr. Vijay. So now we have come to end of question round. On behalf of agricultureinformation.com, we'd like to thank you for a very detailed presentation and answering all the questions in depth. And we also like to thank all the participants for joining this meeting. The meeting will now be closed.
Okay. Thank you, madam. Thank you.
Yeah, most welcome. Thank you.